Hello everybody, this is Mr. McAllen, and I would like to work on explaining the difference between explicit and implicit functions. When you take derivatives, I want to emphasize what it means when you say with respect to. I want to give you a basic picture of what an implicit differentiation process will get for you, and I'm going to do this through the medium of Wolfram alpha. So in our calculus studies, they may ask you to plot a function which is an implicit curve. And when you have that function, it may be difficult for you to come up with a picture of it, so there are various tools available for you to plot it. So what I'd like to have you do is, if you can go to your computers and find this this website called Wolfram Alpha. There may be other websites out there that can do the same thing now, but this is one that I've always enjoyed using and showing to my class. And at Wolfram Alpha, at the menu bar, you just type in plot x squared plus y squared minus 2x equals 0. And when you plot it, you'll get a nice picture of what the curve should look like. And what we see here is we have a function that's a circle centered at 1, 0, and it looks as if it has a radius of 1. Now we all know that this function has the, if you study conic sections, this function would have a equation for a circle that would be x minus 1 quantity squared plus y squared equals 1. Our goal is to take an equation and to understand how an implicit curve relates to or compares to an explicit function. An implicit curve is not defined in terms of any one variable. Notice here we have a mix of x's and y's, and for a lot of functions that are implicitly defined, not functions, but I should say implicit relations, there's not a clear way or easy path to solving for one function, for one variable as a function of another variable. So as a result, we have curve equations that, based on our derivative practices so far, we wouldn't be able to find the derivative. So in the next video that I do, we'll basically show you how to take a derivative of an implicit relation. Before we do that, a couple things that you should understand is that when you take a derivative with respect to of a function, you have to know with respect to what variable you take it of. So if I were to ask you to take the derivative of x cubed without saying what variable, you might just assume, well, I'll take the derivative of x cubed with respect to x, and that would yield a nice easy derivative 3x squared. But if I had asked you to take the derivative of x cubed with respect to let's say y, you can't just stop at 3x squared. That's not correct. The derivative with respect to x cubed of x cubed, the derivative with respect to y of x cubed has two parts. First, you take the derivative with respect, pardon me, I'm saying y cubed with respect to x. You would first take the derivative of y cubed with respect to y, and then multiply that by dy dx. And the chain rule, mathematics, would show that you would end up having 3y squared times dy dx. This is an important thing to understand, is that you need this extra term, because this extra term in here is what relates the change in y to the change in x. And without it, you can't do implicit differentiation. Another example would be if I asked you to take the derivative with respect to t of y cubed. You would have to first take the derivative of y cubed with respect to y, and multiply that by dy dt. Again, the chain rule would allow you to do this. You would have 3y squared, and you multiply by dy dt. What is an implicitly defined function? Again, it's any function that can't be solved for one variable or another. So for example, a good example would be x cubed plus y cubed minus 6xy equals 0. Or as the one we had before, x squared plus y squared minus 2x equals 0. What's a good example of an explicitly defined function? Y equals the sine of x. Y equals x squared plus 3x plus 2, something like a parabolic motion equation in physics, negative 9.8 t squared. Now I'm trying to think of physics, so that would be t squared divided by 2 plus 10t minus 5. These would all be good explicit function equations, and they'd be easy to take derivatives of. These would be implicit, requiring, if you wanted to find dy dx, implicit differentiation. This is really a background video, which is good to watch this if you're starting from scratch and you want to learn about implicit differentiation. So what I intend to do in my next video is to do some implicit differentiation on these functions we just talked about. So if you are interested in learning about that, please tune in to the next video. I'll try to link both videos so that there is some continuity between the two functions, or between the two processes. Thank you for watching, and I hope this video has helped.